In this video we show how to use Fawav to calculate an FFT of data of one variable. Here's a graph that we previously plotted in a previous video. We zoomed in, but the FFT will be calculated for the entire data set, which is shown here. So now we compute Fourier transform, and it is over the interval minus 0.5 to 0.5, so that's minus L to L, and this is the best choice if you're over an interval minus LL. Sometimes we might be over an interval 0L, and this would be typically the best choice. Alright, so this is the default, and that's perfect for what we want here. So now we'll click plot. And there's the Fourier transform. If we now change our view, you can see it a little bit better. We'll go from minus 880 to 880. And for y, we'll go from minus 40 to 40. And there we see, if we compare this with the graph, we have here a frequency of 440 and an amplitude of 40. And you see here green spikes that are the real part of the FFT that are located on plus or minus 40 with heights of 20. That's discussed in our course why those are half of the 40 here because of the complex exponentials that FFTs are based on. But you multiply by 2 and you get the amplitude of the real formula used here. The sign corresponds to the imaginary part of the FFT that's graphed in blue here, and there are spikes located at negative 220 and 220, and so we're getting the frequency information and the amplitude very clearly in this FFT. One difficulty is the fact that we have real and imaginary parts and two graphs, and sometimes those are hard to interpret. Another option is to compute a power spectrum, which we'll do by clicking that option, Fourier transform, then power spectrum, click plot. And again, we have to change to the a little bit better view. And let's see, with a little experimentation beforehand, I found that this is the best Y range to use. And, whoops. The reason we're only getting half the graph there is I didn't put a comma there. This x interval, y interval is a little bit touchy in Fawav. There we go. And so there's the power spectrum. Again, spikes located at the frequencies in the original formula, which was here. And so the power spectrum, as discussed in the course, provides a description of how much energy is concentrated in the various frequencies in the data. Alright, that shows how to graph a Fourier transform in a power spectrum. That concludes this video. Thank you for watching.